In this video, we are going to talk about the halohydrin reaction. The halohydrin is a functional group in which hydroxyl and halogen groups are bonded to adjacent carbon atoms. So let's consider these two reactions. What will be the product from this reaction? This will be the product for this first one. And this will be the product for this second reaction. So this product is actually what is known as the halohydrin product or the halohydrin. Now, what mechanism leads to the formation of this product? So let's show with reference to the first one. So the starting material was this alkene. And then we had a Br gas. So what happens is that, remember that bromine has 3 lone pairs of electrons around it. And because of these pi electrons, this molecule is electron rich. So it comes here to pick lone pairs, to donate its lone pairs of electrons. And that causes this bromine atom to cleave off. And because bromine has 3 lone pairs of electrons, it uses one of its lone pairs to attack the adjacent carbon atom. And then in some form of SN2 reaction. So there is a cyclic brominium intermediate that is formed. So this will lead to this intermediate. With a positive charge. So what happens is that in the subsequent step, this Br minus that we cleaved off will come and attack the cyclic brominium intermediate at the back. That causes the ring to open, and therefore the product we are going to form will be this product where the bromines are pointing in the opposite direction. So there is some form of regioselectivity in this reaction. Let's use mechanism to show this one too. So let's show by reaction mechanism how the second reaction also proceeds. So we'll start with the alkene. So with this alkene, then the bromine gas. So it will use these lone pairs of electrons to attack this bromine, and then it will cause this bromine to cleave off. And because bromine has 3 lone pairs, it will use one of its lone pairs to attack the other carbon, and that will lead us into the brominium intermediate, cyclic brominium intermediate, which is this molecule. And then remember that it's in the presence of water. Water will act as a nucleophile. So because you know that oxygen has 2 lone pairs of electrons. These are the 2 lone pairs of electrons. So it will use it to attack the brominium cyclic ring at the back. And that will cause this ring to open, leading us into this intermediate. Sorry, but I didn't draw this part of the molecule. So there is a Br here. And then we also have the water here. Now you know that oxygen, when oxygen forms 3 bonds, it will have a plus. So we'll use another water molecule inside the system to pick up this proton, so that at the end of the day, the true product will be this. So this is the reaction mechanism for the above reaction. So let's consider this reaction as well. What will be the product formed in this reaction? So there are two different products that can be formed in this reaction. The first one is this. Which of these two products will most certainly form in this reaction? Now, we will be able to know that when we do the mechanism. So let's do the mechanism for the reaction. So there is a Br here. So it will use one of its lone pairs to attack this bromine atom, and the other one will cleave off. And because bromine has three lone pairs, it will use one of its lone pairs to attack the other carbon, so that we can form the cyclic brominium intermediate, which looks like this. But then we have water molecule in the system. Now, will the water molecule attack this carbon, or it will attack this carbon? We'll be able to know that if we determine the kind of carbons that we have. You can see that this is a secondary carbon and this is a tertiary carbon. Now, even though bromine has a positive formal charge, remember that bromine is highly electronegative. And because it is electronegative, the electrons that are shared between bromine and these carbon atoms is pulled more towards the bromine than the carbon atoms. So the carbon atoms assume partial positive charges, and then the bromine assumes a partial negative charge. Tertiary carbon bearing a partial positive charge is more stable than a secondary carbon bearing a partial positive charge, and therefore the OH, which is the water molecule, would attack this side of the carbon and causing this ring to open. So you see that oxygen in three bonds will form a plus or be positive, and therefore we'll use another water molecule in the system to pick up one of these protons so that we can get a final product, which is. So this is the reaction mechanism. So let's consider this reaction. What will be the product from this reaction? So you see that the bromine will add on to this side of the molecule, whilst the alcohol will add on to the side of the molecule. Now let's show the reaction mechanism. So we are starting off with the alkene, and then we have a Br gas in the system. So this one will use its lone pairs to attack this bromine, and this bromine to attack this carbon on the opposite side. But then when he attacks this bromine, it will cause this bromine to move off, and then we are going to form the cyclic brominium intermediate. So now that we form the cyclic brominium intermediate, then remember that alcohol, the ethanol, has is nucleophilic. To use these lone pairs, but remember that this is a secondary carbon and this is a primary carbon. Now, primary carbon, a secondary carbocation is more stable than a primary carbocation, and therefore the nucleophile will attack this side, causing the ring to open, and that will lead us into this product. But this was an alcohol. So in the final step, you see that we have water in the system, or the Br that was thrown off. So this Br minus will come and pick this proton, moving the electrons back here. So to lead us into our original product. So what will be the product formed from this reaction? You can pause the video at this point and then try. It's going to be this product. So the chlorine will be here, and then the OCH3 will be here in the opposite direction. So this will be the product form. So how will this mechanism happen? So we have a Cl2 here. So this one will attack the Cl, causing this one to move off. And this Cl will attack the adjacent carbon. So it will lead us into the cyclic ring. So there's a Cl here with base A plus. Then in the next step, this methanol is nucleophilic. But remember that this is a tertiary carbon and this is its secondary carbon. So the methanol will attack this carbon at the opposite side with one of its lone pairs, causing this ring to open. Therefore, so there will be a plus here. And then the chlorine that was cleaved off will pick this proton, causing this to return here. And that will give us our final product.